Another mathematical concepts of modular arithmetic is determining the specific day in a week. Okay, so before and after that specific day. Okay, so unlike with the time having 12 as our divisor because of the 12-hour design clock, here when it comes to the day, we're going to use 7 as our divisor because we have 7 days in a week. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so we have the same procedure here, but the most important part here in modular arithmetic is the remainder. Okay, so let's have this one. If today is Monday, what day is 16 days from today? So same procedure, we're just going to divide this. So 16 divided by 7, and the answer here is 2 remainder 2. Okay, so quotient will be the reference day, but actually it does not affect anything because we're just going to base it, okay, in our question, in our problem. Okay, so since Monday here is the given reference day, so we're going to use this. And then another one, we have the remainder wherein we have the number of days to be added. If we are after with after or subtracted if we are looking for before. Okay, so in this case, what day is 16 days from today? We're just going to add that 2 days. Okay, we're just going to add that 2 days. So from Monday, you add that 2 days, Monday, Tuesday, then Wednesday. So if today is Monday, what day is 16 days from today? The answer here is Wednesday. Another example, if today is Saturday, what was the day 211 days ago? So same procedure, we're just going to divide that 211 to 7. Okay, so 211 divided by 7, and our answer here is 30 remainder 1. In this case, the keyword here is ago. So therefore, we're looking for the days to 111 days before that Saturday. So that's why the remainder 1 will be subtracted. So we're going to have 1 day backwards from Saturday. Okay, and the answer here is Friday. So again, look at this. What was the day 211 days ago? So since the keyword here is ago, so let's go 1 day backwards. So the answer here is Friday. Another one. What day will it be after 147 days if today is Sunday? What day will it be after 147 days if today is Sunday? So dividing 147 by 7, the answer here is 21, and we don't have a remainder here. Since we are not after with the quotient, we have no remainder. So the answer here is still Sunday. So given that we have the reference day as Sunday, so since we're not going to move, the answer is still Sunday. Okay, the answer is still Sunday. Okay, so the extension of the concept of the day in a mathematical concept using that modular arithmetic is determining the specific day given a particular date in and a year. Okay, so for you to uh, visualize this concept, this application, let's have this one. So here is an illustration. It's just an illustration. If May 19, 2013 was Thursday, on what day will it fall in the year 2022? We know that every single day in a year will automatically move 1 day on the following year, right? So let's say if May 19, 2013 is Thursday, then next year, May 19, 2014 is Friday. So let's just list down this. Let's enumerate. So again, if May 19, 2013 is Thursday, then next year, that is Friday. Okay, and another one, 2015, that is Saturday. Now, how about 2016? Okay, so 2016 is considered as one of the leap years. We should take note that the existence of leap years in the given interval from and to the years that we are concerning for. So as we all know, a leap year happens once in every 4 years. So this will give us an existence of February 29. Since we have an additional day here, we're going to add 1 day. Okay, let's just add another 1 day. So here we're going to have Monday. So one for since it moves for this year, and then another one because it's leap year. And in 2017, again, that is Tuesday. 2018, that's Wednesday. 2019, that's Thursday. And in 2020, again, 2020 is considered as a leap year. So another day, another additional day. So February 29. So therefore, this is Saturday. Okay, so this is Saturday. And then another one, 2021, that's Sunday. Then lastly, for 2022, the answer here is Monday. So given that May 19, 2013 was Thursday, then May 19, 2022 is Monday. Okay, so this one, actually, this method is limited. We cannot enumerate all the time, right? So let's just consider the idea of the modular arithmetic, and let's summarize this. Let's generalize this by identifying the automatic moves and the extra moves. Okay, so for the automatic move, all we have to do is to determine how many years are there in the interval from 2013 and 2022. Okay, so all we need to do is to subtract 2022 to 13, and the answer to that is 9. So this indicates that there are 9 years. 9 years is equivalent to 9 moves of days from Thursday. Because according to the given May 19, 2013 was Thursday, we know that 9 days that we've got are the automatic moves for every year. In addition, we have here extra moves. So the extra move for the existence of leap year in the interval is not counted. So therefore, there are 2 leap years in the interval, which are 2016 and 2022. So we need to add that 2 as our additional move. So 9 automatic moves plus 2 extra moves, that is 11. And then let's apply the modular arithmetic. Okay, and then we have that 11, we divide it to 7, and we have 1 remainder 4. Okay, we have that 1 remainder 4. So we are after with the remainder again. We need to add that 4 days from Thursday. So add that for 4 days, Thursday, Friday, Saturday, Sunday, then Monday. Okay, so we have that Monday. Now, if we are looking for the after years, we have 2 cases to consider. Okay, so we have 2 cases to consider. We have January 1 to February 28, and then March 1 to December 31. So what are the extra moves for this dates? Obviously, for March 1 to December 31, we consider the leap year because the additional day is February 29. So as we all know, during the leap year, the dates for that, okay, the additional date for that is February 29. So obviously, there will be an additional day. Okay, so there will be a movement for March 1 to December 31. However, when it comes to January 1 to February 28, we all know that it happens before February 29. Okay, so when is the extra move? Okay, so the extra move for January 1 to February 28 will be the year after the leap year. Okay, well, it will be the year after the leap year. Okay, so remember that. Now, let's have this problem. This is coming from an actual calendar, so you can verify if our answer here is correct. If February 14, 2021 will fall on a Sunday, on what day will it fall in the year 2036? Okay, so first off, we need to recognize the automatic move here. Okay, so the automatic move here is based on the interval from 2021 to 2036. Okay, so all we need to do is to subtract that. Okay, so 2036 minus 2021, the answer here is 15. Okay, so there are 15 moves. Okay, and then for the extra move, since February 14 will have its move during the year after the leap year, it is clear that for this example, we need to count those years after the leap year. Okay, not the leap year itself. Okay, so let's identify from 2021 to 2036. Okay, so identifying that, we have 2021, 2025, 2029, and then 2033. Okay, so for you to easily identify this, all you need to do is to add 1 to the leap year. Okay, now, look at this. 2021 is not included as an extra move. Why? Okay, because in our problem, it serves as our reference date. Okay, so it serves as our reference date. So therefore, we cannot consider 2021 as an additional move. Okay, because we know that 2021, February 14, 2021 will fall on a Sunday. So therefore, our extra moves now here are 2025, 2029, and 2033. Okay, so let's add that. Okay, that automatic moves and extra moves. 15 plus 3, that is 18. Okay, then let's apply the modular arithmetic here. So 15 plus 3, that's 18. 18 divided by 7 will be 2 remainder 4. Okay, that is 2 remainder 4. Since we have the remainder 4, we need to add that 4 days from Sunday. So Sunday, add that 4 days. Monday, Tuesday, Wednesday, then Thursday. So therefore, February 14, 2036 will fall on Thursday. Okay, it will fall on Thursday. Okay, you can verify it, you can check your calendar, or you can search it in Google. And the Valentine's Day for 2036 will be on Thursday. Okay? Let's have another example. In the year 2020, we celebrated Independence Day on the second Friday of June. On what day will Independence Day fall on 2041? Okay, so first we need to recognize the automatic move. So again, from 2020 to 2041, let's just subtract that. And that is 21. Okay, so our automatic move here is 21. And then for the extra move, so provided that we have the date of June here, okay, and our Independence Day is June 12. So obviously, we need to consider the leap years. Okay, we need to consider the leap years from 2020 to 2041. Okay, so from 2020 to 2041, what are those leap years? So we have 2020, 2024, 2028, 2032, 2036, 2040. Again, 2020 is considered as our reference date. So therefore, we don't need to include this as an extra move. So let's just add this, 21 plus 5, that is 26. Okay, 26, and apply the modular arithmetic here. So 26 divided by 7. So 26 divided by 7, the answer here is 3 remainder 5. So again, we have 5 as our remainder. All we need to do is to add that 5 days. Okay, we just need to add that 5 days. And the answer here is Wednesday. So, on 2041, June 12, 2041, the Independence Day will be celebrated during Wednesday. Okay, on Wednesday. Okay? Again, you can verify it. You can check it in your calendar. And another one we have here, January 1 to February 28, March 1 to December 31, for before years. Okay, this is for before years. Okay, so now the question here is, what are the extra moves to consider for these dates? So again, since we are after with the before years here, we just need to reverse our case from the previous one. Okay, wherein we look for the after years. So for before years, if we're going to backtrack, we're going to look at the past, we're just going to consider leap year for January 1 to February 28. And then for March 1 to December 31, the year before the leap year. Okay, the year before the leap year. So let's have an example. If November 1, 2020 falls on a Sunday, on what day was it fell last 2010? So for the automatic move, all we need to do is to subtract that 2020 to 2010. The answer here is 10. And then for the extra move, since we have here November 1 as our date, we need to consider the extra move for year before the leap years. Okay, we need to consider the year before the leap years from 2010 to 2020. Those are 2011, 2015, and 2019. So for this, all you need to do is to subtract 1 for the from the leap year. Okay, so we have here 3 extra moves. So 10 plus 3, that is 13. And 13, applying the modular arithmetic, 13 divided by 7, the answer here is 1 remainder 6. Okay, so since we are looking at the past, we're going to subtract that 6 days to Sunday. Okay, again, since we are looking at the past, let's move 6 days before Sunday. And the answer to that is Monday. Okay, the answer to that is Monday. So here, we need to consider that we should move backwards since we are looking at the past. Okay? And again, you can verify this in your calendar. November 1, 2010, the answer here is Monday. Okay, in the year 2020, your mother celebrated her 50th birthday on January 20, and it was one of the best Saturdays of happen in your life. On what day was your grandmother gave birth to her? Okay, so again, we need to consider the automatic move here. Okay, and our automatic move here is 50. Since your mother is celebrating her 50th birthday. Okay, so we have 50. Since her age is 50, and we are looking at 2020 as our reference, so 2020 minus 50, that is 1970. Okay, she was born during 1970. Okay, during January 20, 1970. So with this, let's try to identify now the extra move. Okay, so given that our date is January 20, Our extra move now here is the leap years. Okay, we need to consider the leap year from 1970 to 2020. Okay, so from 1970 to 2020, what are those? So we have 2020, 2016, 2012, 2008, 2004, 2000, 1996, 1992, 1988, 1984, 1980, 1976, and 1972. Okay, so again, 2020 is excluded. Why? Because this is our reference date. Okay, we know that January 2020 is Saturday. So therefore, all we need to do is to consider the 2016, 2012, 2008, 2004, 2000, 1996, 1992, 1988, 1984, 1980, 1976, and 1972. So total of 12. Okay, the total of that is 12. Now, let's add that 50 automatic moves plus 12 extra moves, the total of 62. So let's apply the modular arithmetic. 62 divided by 7. The answer to this is 8 remainder 6. Okay, the answer to this is 8 remainder 6. Since we are only after with the remainder, which is 6, let's just move 6 days from Saturday. Let's just go back again. Okay, let's just go back. And the answer to that is Sunday. Okay, so from Saturday, you go back Friday, Thursday, Wednesday, Tuesday, Monday, then Sunday. Okay, so the answer here is Sunday. Okay, so for this problem, this is just this is not coming from an actual date from the calendar, but we can consider this as correct since we follow all the rules.